A warm welcome to all of you. Many thanks for joining us today for this webinar with the title Sustainable Commercial Refrigeration, a cool approach to keeping food fresh of the Cooler program. It's great to see so many people joining us on the call today from across the region and around the globe. Thanks to all of you for making the time to be here with us. My name is Alexander Pohl. I'm a senior consultant at Guidehouse, and I'm supporting the CoolUp team as an energy efficiency and sustainability expert. To celebrate today's World Refrigeration Day, we will discuss in this webinar how sustainable commercial refrigeration can play a role in upscaling sustainable cooling in the Middle East and North Africa region. Let's have a look at today's speakers. For the discussion, I'm joined today by Nesen Surmeli-Anac. Nesen is the Cooler Program Manager and Associate Director at Guidehouse. Nesen focuses on aspects of sustainability in the built environment, both on buildings and building products level, with a strong multidisciplinary background. She currently leads the implementation of the Cooler program in our 4 partner countries, Egypt, Jordan, Lebanon, and Turkey. Our second speaker is Gschrey from Öko-Recherche, who has been working on the Montreal Protocol and the F-gas legislation for more than 12 years. In our Cooler program, Barbara supports us as a policy expert. Our next speaker is Olaf Schulze, who is the Director of Energy Management, Real Estate Sustainability at Metro. Mr. Schulze has been engaged in energy management at the F-gas exit program since 2014. And last but certainly not least, Firas Abdin. Mr. Abdin is a refrigeration engineer who has been active in developing the company Abdin Industrial for more than 30 years. Abdin Industrial is a leading manufacturer of supermarket and kitchen equipment with project references throughout the Middle East. So without further ado, let's get started answering questions from the audience. I would ask all speakers to turn on their cameras, please, and unmute. I'm just looking through the questions. I think we already have some questions here, and the first one would go to Barbara, I think. Barbara, what further activities on the commercial refrigeration sector will be done in the Cooler program?
Yeah, it was mentioned earlier that the commercial refrigeration sector is one of the sectors in scope of the Cooler program. So we will be hosting and organizing different events, such as also in this year still a regional conference where some attention will be given to the commercial refrigeration sector. We will have a number of publications coming soon, and I believe that that's still part of the outlook at the end of the event. We will have technical solutions reports. We will have publications on the market status, and also the Cooler program entails a component dedicated to training. So maybe there is even a potential to cooperate with Abdin further in this field, and that's there will be technician trainings and possibilities to improve the skills of technicians working in the service sector.
Great, thanks so much. There is another question I see here from Mr. Schulze. What are Metro's further plans in the MENA region?
Yeah, thank you for the question. Also, I mentioned it in Turkey as part of MENA, where we are very active. We are starting now with Antalya 1, with our first store, but we like to convert from 404A to Transcritical System. Next year we will have the next 2 one. And then also in 24, 25, every year we like to roll out our F-gas exit program, that we can also say end of this decade, 2030, we are free of F-gases, but in addition, my first page was a metro zero emission strategy. Also in Turkey, we investing not only in cooling equipment, we investing also in new, for example, LED illumination in the store. We like to reduce very strong our energy demand. And what we are really doing in Turkey, we will install more or less top on each roof photovoltaics, that we can reduce our energy by, like Mr. Abdin, with new cooling equipment, our energy demand, with new illumination, our energy demand, and we like to produce not only a small quote, a bigger quote of the demand that we have by photovoltaics top roof, that we are more and more near zero. But 2030 is only the half time. 2040 is the end time, and you can imagine to come to zero emission, we have to do a lot. Then illumination and new cooling equipment is not enough. But more or less, you can say Antalya is now our first store, the pilot. And usually after 15, 16, 17 years, we have refurbished again. Therefore, I believe that before 2040, we will install the next generation of cooling equipment in the store, what we equipping now with ejector technology, transcritical, like in Antalya.
Yeah, interesting. Thanks so much for the answer. We have several questions here. The next one would go again to Mr. Abdin, if you don't mind. The question is there any interest in Jordan or other MENA countries for more transcritical systems?
It's a good question. Actually, I would have to answer in a very honest way. Actually, at the moment, there is no demand on transcritical systems, on CO2 transcritical systems. But we are trying to create the demand of the customers. And the reason there is no demand, people are afraid to use the new technology, especially, as I mentioned earlier, that there is no qualified technicians and engineer to take the responsibility to carry on the maintenance and after-sales service of the system. Okay, in our company we have, but we have 4 or 5 people. We cannot run across the whole region to support say natural gas system. As well, there is no rules and regulations. For example, in Europe, they have banned the use of HFCs, where in our part of the world, we still have until 2045 or 2048 are allowed to use HFC. So if our government do not move and do some new rules and regulation to stop using these HFC gases, people will still use it until they are totally, completely banned. And you will be surprised that we still get some customers asking for R22. And we say it's impossible nowadays to have R22, but this is due to lack of education in our part of the world. Our schools, our technical schools in the MENA region, in the Gulf, in North Africa, they're still teaching the old refrigeration technology with R12 and 502, and they never speak of a new DC inverted technology in new types of gases. So basically, this is a problem. Second one, our part of our market, the region are price-oriented market. So when you come with a new technology, of course, a new technology always have a higher price than the standard technology. So people are not willing to invest in a new technology, especially when you have to pay 2-3 times higher price than a standard CO2 system than a standard HFCs. So if we don't have rules and regulation implemented by our governments, people will never convert into the new technology. But we are, as Abdin, we are trying to play a big role in the market by convincing the people, or trying to introduce technology which suits the budget of our customers. For example, now we are doing a lot of we are converting most of our plug-in chillers into R290 with a DC inverter technology to try to reduce energy as much as possible. And as well, we have invented a new system, a new DC inverter scroll compressors. We are making a centralized system of this running on R448A, which is with a low GWP gases. So we are trying to do as much as possible in our region. But if we don't, as I said, if we don't get support from our government, we will continue with the old technology, unfortunately. And one very important as well reasons, for example, in Jordan, in Jordan, when we speak to our customers, we speak to the owner of the supermarket, where we can convince him to go into new technology, and he'd take a decision. And let's say if the system doesn't work, the owner took a decision, so nothing can happen. In other part of the region, like in the Gulf region, usually we don't deal with the supermarket owner or with the high-end management. We are mainly dealing with a purchasing manager or a project manager. And we speak and talk and explain and convince. You're talking really nice. We are convinced, but we want to stay with the traditional system. Why? Because if the new system it doesn't work, we will lose our job, and we don't want to lose our job. So we want to stay with a standard known system which has been tested for many years. And if we come to the Gulf region, the idea here, a chiller must use a hermetic condensing unit with a very high energy consumption. Freezers or low temperature application, semi-hermetic compressor, full stop. You go to a supermarket with 20 cabinets, you will see 20 condenser units hung on the wall, each cabinet fed with a single compressor. And this is where energy consumed are very high. Now, I have been in Dubai for the last 2 years, living actually spending most of my time here in Dubai. And we have started slowly to change the idea and to prove to the customers that a new technology, okay, using the low GWP gas like 448A, can work, can save energy, and as well we can start to protect the environment in the countries to have sustainable energy, and then we slowly start to convincing the customers on using a plug-in chillers with R290. In the beginning, wow, this is flammable, our shop will be burnt out, we do this, and no, and then we show them it's not. The system is so reliable. The components are used. It's a high reliable, durable equipment which can run without gas leak, without anything scary to burn down the supermarket. And I always tell to my customer, I said, our chiller has maximum around 150 grams of gas charge, but at your home, in your kitchen, you have a bottle of gas with a 20 kilogram sitting in your kitchen. This is a bomb. Not a chiller in a supermarket with 150 grams can cause a fire, a hazard into your supermarket. So slowly, we are convincing. It takes time, but we will never give up. And we need our part of the world to be green. And we need to push our new technology. And I have one of my son, now he's doing a master degree in CO2 refrigeration system in Norway. So we want to push more and more this technology, this idea, educate people, not just sell and make money, but we really care about educating our people in our part of the world.
Yeah, thanks so much for this answer. I think we have a nice question that is a little bit connected to the question that Mr. Abdin just answered. It goes to Nesen. What are the key hindrances to the adoption of these more energy efficient systems in developing countries? Is the issue upfront costs? Is there a need for policy change promoted by the public sector?
Yes, thanks for the good question. And I think Mr. Abdin has already outlined the challenges that we see in the developing countries in the region, but also I would say in many other parts of the world. And they are quite similar to all energy efficient technologies that have faced throughout the last decades. It starts with lack of awareness, lack of regulatory support, lack of technical capacities, lack of right curricula or updated curricula in high schools and technical schools. Those are like Mr. Abdin has said, all components that comes together and hinders the development of those technologies in the countries. What CoolUp is trying to do is exactly to try and point on all these challenges on different aspects. We work with country governments to support regulatory development. We are working closely with Jordan government, and they are really committed and interested in the CoolUp project. We are really honored by their interest, and we are working on several different layers of regulatory update together with our local partner NERC. In addition, in all the partner countries that we have, as I said, will have an extensive capacity building program, not only targeting manufacturers and technical service providers, but also decision makers on the supply chain or the value chain of whole construction sector for air conditioning and refrigeration. This would obviously also include the commercial refrigeration purchase decision makers, which Mr. Abdin nicely highlighted. On the air conditioning sector, it also, of course, includes building mechanical engineers, architects, and system designers. Yeah, so we are going to work on all these aspects, and we have quite nice time ahead of us. Hopefully, we will see some acceleration by CoolUp input in the target countries. Thanks, Alex.
Yeah, thanks, Nation, for that answer. There is actually another question to Mr. Abdin, if you don't mind answering. It goes, in winter, is the CO2 system working on subcritical mode, or is it transcritical operation?
Subcritical, because in Jordan we have it in winter time, temperature could reach to 0 degrees C. So we will go into a subcritical mode. Yes.
And then there is another question for you. It is, can you share with us how R290 systems differ from CO2?
R290 have different applications than the CO2 applications. Of course, R290 is still a green gas or natural gas, I would say, but has a different application and a limited cooling capacity due to the limited charge into the chiller. But in terms of efficiency, in terms of green technology, it has a similar efficiency to CO2 system. When we speak of centralized cooling system, both are green, but have different properties. So we cannot really compare CO2 with a centralized system into R290 with a plug-in system. But we can say they are both green and natural gases.
There is another question for you, but I think you already answered it somehow. It is, what is the technical advantage of using natural refrigerants? How would utilizing CO2 reduce the energy consumption?
Yes, using it is first of all, it's a properties of gases, the efficiency of the gas, the boiling point, and as well using ejectors where actually mainly energy saved by using ejectors into the system, where actually ejectors work as a compressor but without electrical motor. And that's why we say in summertime, we are saving more energy because ejectors are working more, they perform well with high ambient temperatures. That's where CO2 comes into, it starts to save energy compared to the HFCs gases.
Alex,
thanks so much for the answer.
Alex, I can
go ahead, Mr.
I can
Schulze.
underline it. Yeah. We have in between also in Europe, there's a higher temperature, the peaks in the summer, and therefore the resistance against the temperature for CO2 is definitely higher than for conventional systems. We have less problems, less technical problems when we have here also 38, 40 degree. Yeah, in Jordan it is standard, but in Germany 40 degree it is ultra hot. But the condition, also with the CO2 transcritical equipment, we will survive technically also such temperature by relatively constant electricity, but definitely we have less interruption of the equipment. And with the conventional, we have it more often. Therefore, I can only underline the Mr. Abdin what you are saying from my experience.
Yes, actually, with our I would say limited experience with CO2 systems, since we have done only one system in Jordan, but we can see the durability and reliability of component used in manufacturing CO2 working equipments. Compressors are more reliable, are built in a very strong, reliable way. Electronic expansion valves, all component needed to be used in CO2 system is being done in a more reliable component than it used, which we are using in HFCs. And HFCs are more into commercial equipment, have a limited life cycle, where we can see from CO2 system, from our experience, honestly, we have never ever been one time to maintain the system. We have never had one breakdown. We go just by ourselves. We have a program every 3 months just to go and clean the gas cooler from dust. That's all what we have done since day one of installing the system in this supermarket. And by the way, I remember it took us more than we speak about the difficulty of pushing natural our CO2 systems in our part of the world. It took us 1 year to convince this customer to install the system in his supermarket. Even he had not to pay a single penny. It was funded by UNIDO, and so the customer, he had to pay nothing, but it took us 1 year to convince him to let us install the system in his supermarket. One of the people came, 110 bar pressure in the system. It's a bomb in my store. It will explode. I said, nothing will explode. The gas, maybe people will be poisoned. People will die if explosion happens. Why explosion to happen? And then we have to involve Ministry of Environment to push and to convince the customers. The project was 1 year delay until we were able to implement it. And then we got another project to do in Tunisia, but it didn't go until now because the customer, he's afraid of something happened in his store, and then the program was cancelled. We more than 2 years it took us to try to convince a supermarket chain in Tunisia to install the same system as we have done in Jordan, but unfortunately it was rejected. People are afraid to go to the new technology, unfortunately.
Yeah, thanks so much. I think we have time for one last question, if I'm just looking on the time. It goes to Mr. Schulze. How expensive are subcritical CO2 systems compared to conventional?
So honest, this question I cannot answer, but only because my last subcritical system what we installed in Metro, it was years ago. The 69 subcritical will be constant. There will not be more, in doubt less, but the transcritical will strongly increase. Now 153, and the end of next year we will have more than 200. But therefore, when I can answer transcritical versus conventional, in the beginning, honest, the transcritical were more expensive in the beginning. But in between, the whole industry moved nobody from us is asking what is a price comparison, because we are winning ever with the total cost of ownership. In the theoretical case, when the transcritical system is more expensive, some digit thousand euro, we will win after few years with a lower energy demand, with a lower maintenance repair. In the end, I will take the arguments of Mr. Abdin. It could be in Jordan you have 30%, in Bulgaria only 20%, and in Netherlands only 18% savings. But the savings are usually so high that we are winning ever during the life cycle, and not in year 15. We are winning in year 5, 6, 7, when we would have. It's only a potential higher cost for a TC system versus a conventional R448A or whatever system. I hope this answer is okay and reliable, but with subcritical, it is old-fashioned for me. I cannot say what is really happening.
And I would like to point that if they want to know the price, because we work with both systems, I know the price difference in between the two systems. The transcritical system is around 2 times higher in price than an HFC. If we take centralized cooling system with the same capacity of cooling, then transcritical is around 2 times higher in price than the standard HFC as well. Not just the system. We speak of maybe the gas, the CO2 is much cheaper as a gas, but again, if we speak of the piping, the special copper pipe are used in CO2 systems, which are more expensive. But if we speak in generally, once we made the calculation, how much or after how many years will the customer get his money back in investing on transcritical system, I would say around 4 to 5 years he will get his money back from energy saving, from food wastage. It will take 3 to 4 years. And let's say, taking into consideration the cost of energy in Jordan, the customer need around 4 years to get his money back, which is I wouldn't say it's a long period, because if we stick the lifetime of the system, it is usually 10 to 14 years. So you still have another 8 years to put money in his pocket, I would say, or to save money.
Yeah, thanks so much. So we see that there is a lot of interest, and I think it would be a good idea to do a dedicated, more technical session next time or in the near future. Don't you think, Nesen, Barbara? Yeah. Unfortunately, we are approaching. Sorry, yeah, go ahead, Barbara.
Yes, I think that sharing these experiences, not just from EU, but also in the countries and throughout the world, is actually key for people to pick up on technologies that are like maybe new to them at that very moment, but that are not new to the technical scene any longer. And that's like a really important awareness raising and information part I think we should support in the program.
Yeah, definitely. Unfortunately, we are approaching the end of our time together, so I'm afraid we have to bring this very interesting Q&A session to an end. So there is much more to come, and see you in the next webinar.